Hello all. Today we are going to introduce you SmartODI, an SQL to ODI conversion system. The system fully automates conversion of SQL statements by any complexity level into ODI code within seconds. The conversion results will be mainly as an ODI 12C mapping, but also package and scenario output is provided. After the conversion, the system also provides source to target mapping document as an additional delivery. All these results enormously increases the development speed from days or weeks into seconds or minutes. Further, as the system avoids the unit test needs, it also speeds up the overall testing process. Within this diagram, we would like to show you the overall system flow and how it works. Firstly, the input SQL statement or statements are entered into the system one by one or as bulk entry. Secondly, the template indicating how the resulting data should be processed is selected. The selected template enables the processing of input data such as type 1, type 2, or delta into target tables. As output, the processed SQL statement ODI code is generated by means of mapping, scenario, or package, which are optional output modes. Further, as indicated earlier, the system also provides the source to target mapping document automatically. Now we would like to proceed with a live demo of the system. As the first step, we provide a username and password to enter the system. The system has its own security controls but also supports LDAP integration. After the user authentication, we are diverted to the main screen. We select the SQL to ODI mapping button and the latest used ODI repository will be shown here. Within this demo, we are going to show you a sample SQL statement to be converted into ODI code. First of all, we enter the SQL statement into SmartODI by means of entering SQL, copy and paste, or accessing SQL Excel files. Mapping name and target table parameters are added to the end of the SQL statement, where additional parameters can also be added. Alternatively, parameters to be used for ODI mapping can also be entered via templates prepared by a system admin in order to provide a generic standardization. As the next step, the template is selected and parse processing will be started. At this stage, the system prepares SQL statement details, breakdown of all components, and source to target mappings, such as source mappings, joins, and related tables and column information can be seen. Let's check a sample source item. This sample source item includes two subqueries linked via union, having their own mappings, sources, and filters. Let's check a sample subquery filter. Here again, you can see its own mappings, sources, and filters. In order to have a satisfactory demo, we deliberately selected a complex SQL statement which includes with closed, aggregation functions such as max, sum, subqueries in where closed, distinct, and various Oracle functions like toNumber or NVL. Subqueries as source, set operators like union or intersect, Oracle untick functions, joins both in ANSI or Oracle syntax, and case when clauses. The next step is the optional validate step. At this step, the system performs all checks and controls and provides results as OK or error. If an error is identified, the error's details is specified, such as table not found, field not found, or similar. At this level, the errors should be corrected and the statements need to be reprocessed. Once the validation is completed with no errors, we can proceed with the create mapping step. The system is fired by processing the create mapping button, and within seconds of time, the SQL to ODI mapping is completed. At this point, we validate ODI mappings and reach the same stage as it would be reached via ODI Studio. All codes shown in ODI Studio are created as ODI 12C version. The created code is fully in line with data lineage standards, and it can easily be said that the code results are created as if created by a senior ODI developer in line with industry standards and best practices. Each subquery is created as a separate flow using ODI 12C components and not as a simple hard-coded entry. Besides the single entry just shown, a SQL statement can also be entered into the system as bulk. In other words, tens of SQL statements can be processed at the same time. Each SQL parse results can be seen and checked within the tabs. By pressing the validation button, summary results can be monitored from a single screen, and if needed, details of each SQL statement can be checked. The same process steps as shown before for single statement processing is also applicable for bulk processing. To further provide input flexibility, the system accepts and saves SQL statements as copy and paste, where template selection is possible from a combo box and parameters can be entered through text boxes. Save statements can be exported into Excel files if required so. Similarly, any Excel file with same format can be imported and accessed from the system as saved records. At any time, saved records can be selected and processed by the system to be converted into ODI mapping. The system can be easily used for any ODI project, whether at beginning, already advanced, or even already in production stage. A very applicable way would be Oracle 11G to 12C migration projects. One of the main highlights is that the conversion to Oracle ODI 12C will be made without using Oracle 11G legacy components. The system can also be used for improving coding standards. Existing hard code and non-data lineage code can be converted into 12C industry standards in high-quality results. As a short summary, any project that provides SQL input can be converted easily into a successful Oracle ODI 12C project. Thank you for listening, and we hope to contact us.